Right, so I'll be using this video to try my best to go through the stuff that we had to do for console, sharing the stuff that I know, but as I said, some might want us to do it differently for some parts, but at least it's a start so you can get accustomed to using the system. So, as I said, it may or may not be what you want in some parts, but I'd watch this stuff. So I'll show you what he wanted to know, the basics, and anything else if you want it a different way, by all means we could implement it that way. But this is our start. So the first thing we have to do for the model blueprint is the model. So like what exactly we're gonna design. So there's a stem, a cylinder, there's a fruit. Most people will just pick a cylinder to do it. So you have to like put a diagram in terms of your dimensions. So for this, you'll have to do your research in terms of the dimensions you want to use. But for simplicity, based on what I showing you all, that that's going to like make up values and kind of use it in console just to make life easy. So I started in Paint. So okay, just use this to go. So let me say this. There's the top view. So like this, looking at the cylinder from the top. Say the radius is we can say 5, just to make it easy. So 5 centimeters. So now if you look from the side now, let me say the height is 50 centimeters, and down here will be twice the radius, I believe. So it'll be 10 cm. So that's how I have a plan in terms of the variables that I want to use. So from here, so that's for those are kind of slow. There's the radius. So that is this here. And twice the radius is the diameter. So just to be safe. So your diameter is basically the same thing as this from here to here. So kind of the same. And here the height. So this is basically the stem, a portion of it. Um, that is that piece. So we have dimensions. So the second thing we'll go to is this Excel sheet. It's supposed everybody supposed to have it, but I'll just put it in the description just in case anybody want to use it. So what else to do kind of guide it through the other stuff they have to put into console. So I'll just walk you all through. So these are your model parameters. We don't really have to touch these. These will most likely be calculated for you. So the stuff in red are your stuff. So the height, I think the height was still 50. The separation, we will come to this just now. So the electrode length was 10 centimeters height. So this, the electrode is basically what connecting to the stem. So let's go through that. I think I'll also. So you have your stem, a cylinder, and on the stem you're trying to put electrodes to measure voltages and currents. So we understand that the stem and the electrodes have two different things. So the electrode sticks or wraps on the stem. So everybody can agree that the electrode cannot be bigger than your stem. It's got to be smaller. Okay, so if the height of the stem is 50, and down here now we have the radius of it. I think our radius was 5. So up here we'll calculate the circumference and well the length, which is basically distance around the shape. So the first thing you will do is put in your height and the radius, and I will calculate the circumference, which is important, the distance around your stem from any point to the back around to the same point. So technically the distance, which you'll see the importance of in a bit. So we have the height and we have the radius. Then we have to deal with the electrode. So remember, the electrode cannot be bigger than the stem. So since the height of the stem is 50, we could use 10 cm, the height of the electrode. It have to be less than 50, so you could use 2. Remember, as an electrode could be small. You could use 10 centimeters if you want to. And the length, or if you could say width, if it kind of easier to say width. So kind of weird word to say, and the width of it. So the width of it, remember, it cannot be too wide because remember, the circumference is 31. So you don't want it to be too wide. So you could say 2 cm electrodes, or if you want to get up to 5 and call it a day. But you will see why this, you have to be careful with this value that you cannot throw your answer. So then you do your electrode. So there's the electrode. So this is in cm for the electrode. So you have stem, then the electrodes that are going to stick onto it. So you have the height and you have the width. Then you have the separation, because you have to separate the electrodes with a little bit of space. So in this case, let's say we separated them every 2 cm. So you have space, electrode, space, electrode, space, electrode. So assuming we're doing the 4 electrode system, we'll have 4 electrodes and spaces in between it. So that's your recap section 1. You don't need to do anything with these two. They are calculated for you already. So you have to calculate, you have to put in your height of your stem, the radius of your stem down here. Then from your stem you're going to the electrode, so the width and the height. Keeping in mind that the electrode have to be stuck onto your stem, so it can't be bigger than your stem, because then it wouldn't be the electrode. And then now we put the separation, which is the space between each electrode. So that is the end of section 1. Then you'll go across to section 2, and this kind of laying out or trying to see if the dimensions you pick for the width of the electrode and the spacing, if it will be more than the circumference, because if it's more than the circumference, therefore you have a wrong estimation, so you have to go back. Remember, this here is the circumference. It's like if you have a roll of foil paper and you like roll it out flat, that will literally be the length. So whatever you assume for your separation and a electrode width, when you cumulatively add the spaces and the 4 electrodes to go around, it have to fit. If it's more, that means it's not going to fit. So you have to pick a smaller width and a smaller separation to fit in. So dash. So we have space. So there's the first space. Assuming that we start with our space. So the first space is 2 cm. Then we have the electrode. So you kind of cumulatively adding up the distances. So if you kind of double click on the equation, it will be the electrode plus the space, which is this. Let's start with that. So that is 7. So that is the electrode. So we had 7 centimeters so far. Then you add our next space. Then you add our next electrode. Then you add our next space. Another electrode, space, electrode, and the total is 28. So this inequality box here will let you know if you're within or if you're outside. So yes, so 28 is clearly less than 31. So let's say we were to increase the separation to 5. So if you also increase the separation to 5 now, your distance, your total distance will be more than your circumference. So we know. So you can't use that spacing because you'll go over. So let's go back to what we had to. And once it runs, yes, so you're good. 20. So remember this, what this means. If it kind of confusing is I'm going to paint. Yeah, I don't really care. So let's say this is your circumference rolled out on a flat piece of paper. You have electrodes. You have one electrode, then you have a next electrode, 2, 3, and 4. So the spaces in between. So let's say I'm gonna use the fill. So you have a space here in red, a space, a space, and a space. And then the purple are your electrodes. So remember this from here straight down to the end. That is your circumference. And you have your space. Put it in black. So you have a space. Then you have a next space here. Oops. I don't know what that is. Then you have a next space. Space. I don't know. Kinda goes back around, but you know, small thing. So the space, that distance, then you have a distance for the electrode, then distance with the space, the electrode, space, electrode, space, electrode, and then after that it really decay. Once you stick the electrode, remember the electrodes don't have to go straight around. It could be in a specified space on the stem. It don't have to go around equally, so it could just be in a small space. But you have to make sure that the 4 electrodes with the spaces could fit on your stem. Right? So it's basically what we're trying to do here. Because if, let's say, you can't adjust the width of the electrode, the only thing you could change is your separation. So if you pick too big of a separation, you will run the risk of going over your circumference. So you wouldn't be able to fit the electrodes with those spaces. So you have to pick a spacing that allows you, or you could adjust the width of your electrode because how thick the electrode is to fit. And once you do that, you should get a yes, and you can be happy. So after that, when you realize it fitting, now is to get the degrees, because this will be important to put into COMSOL to actually get the angles. So in this model here, we are assuming that we starting with a space. You could start with the electrode, but yeah, you could just start with a space for this one for simplicity. So the starting angle will be 0, and you will know what this is. Reason why is you're trying to calculate the angle based on the distance of the space. So you gave a separation which is 2 centimeters. So what we did here is actually calculate. So S is equal to R theta is the same radius, and you have S which is the 2. So if you want to make theta the subject of the formula, theta will be S on R, and it just convert it to degrees, and you get this. So this is basically the angle, or you can say the separation in terms of degrees. And down here you have the electrode width in terms of degrees. So each electrode subtending this angle and each space subtending this angle. So what we could use this to do is to get the cumulative angles in which each electrode will start and end at. You don't really care about the space because you're not going to put the space into COMSOL. It's kind of understood, but you need to know what your electrodes starting and ending at. So space, start at space. So it's starting at 0. You can start this at any angle you want to. Either start at 0 for simplicity, and obviously will end at the space in degrees. Then now the first electrode will start at where the space end, and it will go. So this basically is your starting plus the spacing for the electrode. And you just repeat the space, then after the electrode is our space. So you just add the angle for our space, which is, yeah, okay. Yeah, so it'll be this plus the angle for our space. And then you just repeat the process. So electrode, then our space, electrode, space, electrode, space. Any Excel sheet, all you have to put in, well, this will be calculated for you. You don't really touch anything here. But this is basically what you'll get the start and the end angle, and well, you could change this to whatever you want it to be. So it would just kind of change up the values in terms of where it's ending and starting. So if you have to do that now, you'll have to use your 50 and then this will just be 50 and plus the angle for the degrees, and that will just change up your whole system. So now your first electrode will start at 72 and end at 130. So this is really where you're putting into COMSOL, and you'll see as we get into it. So far, you should section 1 your parameters, section 2 getting to see if it fits in on your stem. So you want it to like not go straight around. So this kind of good enough, 28. So it actually taking up 28 centimeters of your 31 centimeters of your stem. And then here you get the starting and the end points for your electrodes, which now we can actually go into COMSOL and model it. So hope that helped, and we'll start the COMSOL in the next video. So later.